Good evening, guys. Today we're going to talk about being able to find systems of linear equations solutions, which means that break-even point at which the graph crosses, or that point at which in the table that the two values are equal. All right, go ahead and title this Graphing Systems of Linear Equations. Your essential question that you're going to answer and we're going to check tomorrow is, how do you solve systems of linear equations? First off, the definition of system of linear equations is set of two or more linear equations in the same variable, so x and y usually is how we're writing x comma y. Solution is the point at which they're equal, the point of intersection, same thing. There's 3 steps that we go through when we're graphing. All right, if I went too fast, go ahead and pause. All right, let's go over 3 examples, easy examples, before I get to the hard example. First one, the first step that we do is 1, graph it. So our first equation, this is equation number 1, and this one's equation number 2. You have to have 2 or more. So equation number 1, our x-intercept is -1, put a point at -1, and our slope is up 1 over 1, up 1 over 1, up 1 over 1. I'm just going to keep putting my dots all the way throughout the graph because I don't have a straight edge on my computer. Up 1 over 1, up 1 over 1. All right, I'm looking for my break-even point, so the point at which they cross. This is the easiest way to visualize where the graphs cross without getting into algebra. All right. Graph 1 is done. Graph 2, I'm going to do graph 2 in purple. The intercept is +3, so 0, +3, and our slope is down 1 over 1, down 1 over 1, down 1 over 1. All right, I found a place at which they cross. That's called the point of intersection. That's your system's answer, and that's 2, 1. Number 1's answer is 2, 1. All right, I'm going to have to clear my page, make some room. All right, question number 2. Graph it first. So this is equation 1. This one's equation 2. Let's graph equation 1. We have +14. My y does not go up to +14, so let's pick 2 points to graph. All right, for equation 1, I'm going to pick, when I plug 1 in for x, -5 times 1 is -5 plus 14 is 14 minus 5, goodness, 9. Great. So I'm going to plot that 1, 9, 1, 9, and then my slope is down 5. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1 off my graph, so I'm going to stop with those points. All right, graph number 2, I'm going to put in purple. I have enough room for graph number 2. The intercept is at -10. Put a point at -10. The slope is up 1 over 1. Up 1 over 1. I'm going to follow my slope until I find the point at which they cross. I don't have to approximate it. It is exactly 3, -6. The answer to number 2 is 3, -6. I'm going to erase my page, so pause if you didn't get all of that. Question number 3. This is equation 1, equation 2. You have to have 2 or more. The first one, x equals y, remember, it says +0 when it doesn't have that written in there. 0, 0 is the intercept. Then we're going to go up 1 over 1, up 1 over 1. Now follow this because I don't have a straight edge. Continue throughout my whole window. So step 1 is graph them. Step 2 is approximate, so I'm still finishing up step 1. Step 2, we'll get to when I figure out where they cross. So our second equation, the intercept is at 1, so put a point at 1. The slope is up to right 1, 1, 2, 1, 1, 2, 1 Oh no, I'm getting further away from our point, so I'm going to work backwards. 1, 2, 1. I found the point at which my purple and black intersect, so the solution to number 3 is -1, comma, -1. -1, comma, -1. Okay, let's go ahead and make them. Alright, examples 4 through 5 4, 5, and 6 are a little bit harder because we don't have them all set in y equals form. So we're going to get our first equation is in y equals, our second one is not. So let's already get y equals for our second equation on number 4 by taking away x from both sides. Y equals -x plus 2. Now we're ready to graph. Our intercept for the first equation is -7. Our slope is down 4 over 1. 1, 2, 3. Oh, it goes off the graph, so we're going to go backwards. Up 4, left 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Let me double check that one. Yep. 1, 2, 3, 4, 1. And now we have enough information for that one. Let's go ahead and graph our second equation. +2 is our intercept, and our slope is down 1 over 1. Down 1 over 1. Down 1 over 1. Right 1. It's getting further and further away, so we'll look backwards on this one too. Up 1, left 1. Up 1, left 1. Up 1, left 1. They intersect perfectly, and so the solution to this one is -3, +5. You can go through and check your answers by plugging in your solution into the two equations given. Remember, you don't have to get a wrong answer because you can plug them in and see that anytime you plug in -3 for x, you should be getting out 5 for both equations. All right, I'm going to erase my page. Problem number 5. Equation 1 is not put into y equals, so we're going to set it equal to y. Take away x. Take away x. Now we'll have -y equals 5 minus x. We want y to be positive, so we're going to flip the signs of everything. So right down here, flip the signs of everything. Y, the opposite of +5 is -5. The opposite of -x is positive x. And we did it. Let me write this in the standard form that we usually write it. Our second equation is not okay because it's not in y equals either, so let's go rewrite that. We'll add 3x, and our second equation should say y equals 3x minus 1. We're ready to graph. Graph our first equation. Intercept is -5, and we go up 1 over 1, up 1 over 1, up 1, right 1, up 1, right 1. Going to keep going until I think I have enough points. And go the opposite direction just in case. All right, now we're going to graph our second equation. -1 is our intercept, and we'll go up 3. 1, 2, 3, right 1. 1, 2, 3, right 1. I'm getting further apart, so I'm going to go the opposite to get closer. 1, 2, 3, 1. 1, 2, 3, 1. Blue and purple intersect finally, as our solution is -2, -7. We can check it by plugging into the equation. All right, I'm going to erase. Last example before you have to do your practice problem. Our first equation is not okay because it's not in y equals, so we'll take away 1/2 x from both sides. Y equals -1/2 x minus 6. Don't combine them, they're not like terms. Or set our second equation to the proper format. So we'll take away 6x, take away 6x. All right, 2y equals 8 minus 6x. Divide everything by 2. And our second equation should say y equals 8 divided by 2 is 4. 6 divided by 2 is 3. And a negative divided by positive is -x. Great, we're ready to graph. Equation number 1, -6 is our intercept. And we go down 1, right 2. Down 1, right 2, down 1, right 2, down 1, right 2, and I'm going to finish this pattern off so I think I have enough room. Go the opposite to the other side, up 1, right, left 2, up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. Great. Let's go ahead and graph our second line. Intercept is positive 4, down 3, right 1, 1, 2, 3, 1, 1, 2, 3, 1, 2, 3, 1, 1, 2, 3, 1. That's where they cross. The same color, the different colors. 4, -8 is the solution. All right, go ahead and answer this one question on your own and pause when you're ready to go over it. All right, you should have gone through and graphed and found that 1, 5 is where the two lines cross each other, so the solution is 1, 5. All right, good luck on your tip points. See you tomorrow.